Morning, dear student. Yesterday I had taught you about the cause of viscosity, and today I am telling you about the coefficient of viscosity, how to derive the expression for coefficient of viscosity. If you know about the viscosity, and this is just like a friction force in the solid. In case of liquid, we are studying coefficient of viscosity. So what we had assumed, let there are various layer of liquid, and having the specific distance between the each layer is dx. As you are observing, the velocity is getting changed as you go from bottom to top. So let the difference of velocity between any two consecutive layer is dv. So that's why dv upon dx is called velocity gradient. So in case of viscosity, the velocity gradient is directly proportional to the area. So you can interpret it properly here. In case of viscosity, let the velocity here v and dv is the change in velocity. The distance between two consecutive layer is dx. Area of each layer is a. So we say here velocity gradient. So how to derive the expression for the viscous force? So we say the viscous force F is directly proportional to the area of contact or area of layer. That is, F is directly proportional to a, number one. Number two is F viscous force is directly proportional to velocity gradient. This is dv upon dx. dv means velocity change between two consecutive layer. Dx is the distance between these two layer. Adding these two together, these equation 1 and equation 2 together, so we are getting F is directly proportional to a into dv upon dx. Replacing this proportionality sign there, it becomes, there is a new coefficient that is called eta. Name is eta and representation is like n. So n into a into dv upon dx, where n is called coefficient of viscosity. Now from here you can define what is the coefficient of viscosity. So he is saying that a, let the area of each layer is a and velocity gradient is unity. In that case, viscous force becomes equal to, numerically equal to, coefficient of viscosity. So coefficient of viscosity of a liquid may be defined as the tangential viscous force required to maintain the unit velocity gradient between the two parallel layers of each unit area 1. The same way you can derive the expression for the dimension of coefficient of viscosity by substituting the unit of f, a, dx and dv simultaneously like this. So this is the dimension of coefficient of viscosity, that is ml minus 1 t minus 2. Thank you, and I will continue this topic next.